Hey, what's going on? Hopefully you watched my most recent video on classes, which kind of explains the context of classes. What does that word mean? What does instantiation patterns mean? What's the point, right? We kind of talked about how all the instantiation patterns effectively do the same thing, right? They all create a class that produces instances, and they just do it in different ways. Now, I want to explore the differences in those four different patterns because, again, they do the same thing, but there's a few details about how they do it differently. And it's very important you understand this such that you can understand concepts like memory efficiency and the keyword new and these different instantiation patterns that will come up a lot as you continue your journey through JavaScript. So I'm going to start off with a metaphor here. Let's imagine we have a chef school that creates chefs. So if you remember our last video, you'll pretty intuitively grasp that the chef school is the class and the chefs are the instances, right? Now, I want to ask a tricky question here. If you were in charge of the chef school, how would you train your chefs to memorize all the different recipes they have to make? Right? Like on any given day, a chef may be asked to make spaghetti or gorditas or, tteokbokki or borscht, whatever it is, just hundreds and hundreds of different recipes. So I want to explore this question of how would we imagine that a chef would remember recipes? How would a chef school train its chefs to remember their recipes? What technique, right? So, in other words, what would actually go inside their mind? Like, what would they remember? Now, this question I just posed to you is the fundamental difference in instantiation patterns. The different instantiation patterns have a different opinion about how the instances of a class should know their functionality. Okay? This is the fundamental way they differ, and so throughout this lecture, we're going to be exploring real-world examples of different ways that chefs could remember their recipes, and we're going to apply it to how the different instantiation patterns teach their instances to know their methods. Okay? I've thrown a lot of vocabulary at you right away. As we get into this, it'll start to become clearer. So, give me one sec to switch something over here. Okay, sorry about that. And just to go over again, in case you missed it, in the last video, you should intuitively know that the chef school is a class and the chefs themselves are instances, right? In code, chef, remember, a class is uppercase, so chef here is going to be uppercase C, and then the instances are what is the result of invoking the chef class. And again, an instance is just an object that a class returns, okay? So let's go back to this question. How is it that you should train chefs to remember all the different recipes? Well, let's just go right now with the simplest solution. Maybe this isn't the best way, but it's so obvious, let's just start there. What if we just make every single chef memorize every single recipe, just straight off, right? This is called functional instantiation pattern. The idea that every instance in its own head has memorized every method is what the functional instantiation pattern is. So in the chef's mind is stored literally like hundreds and hundreds of memorized lines of text. When you say lasagna, the chef goes, I have lasagna, I have an entry for that in my mind, and I've memorized the ingredients list. So I know exactly what goes into it, and I've even memorized the instructions. I know just off the top of my head I have to cook noodles, I have to put them in the pan, I have to do ricotta, then I have to do sauce, then I have to do sausage, I have to do another layer, then I know you have to bake it at 350 for, et cetera, right? Now, this chef might have hundreds and hundreds of recipes, so imagine how difficult that'd be to memorize. Again, it works, but it's just not super efficient, right? Let's imagine what this would look like in code. So we have our class here, just a function. Remember the rules, if it's uppercase, it's the class, it's the factory, it's the constructor. If it's lowercase, it's the actual instance. So uppercase C chef, think of it as the chef school. It's the thing that actually creates the chefs, right? So we build the actual function, and like always, our chef, our instance is actually just an empty object. Okay, lowercase chef is just an empty object, and we're going to return that. Okay, simplest version of a class. We're going to add one more thing here, which is we can add a parameter to customize each instance of the chef at invocation. So hat color, when you invoke the chef function, you can set a hat color, and then we will actually just set that onto the chef object. Remember, objects can have properties, and so we're giving the chef object the property hat color, and we're going to set it to the user-defined hat color. So on runtime, this function will be invoked, and hat color will be replaced with a string such as white, black, red. Okay? Now here's a question I want to pose to you. We just talked about this instantiation pattern. The real-world example of it is each chef memorizing every single recipe. So I want you to try and think for a sec, how can we take that metaphor and apply it into the code here? Where should the methods go? Well, just like hat color, which is directly on the chef object, so are the methods. The methods all go on the chef object. Make lasagna, make cannoli, make bruschetta. These are all functions, and then just imagine there's some functionality in there. I'm not going to write code that actually makes lasagna, trust me. So again, here, every time you invoke chef, the chef class, you get a chef instance that in its brain, so to speak, has all the instructions of how to make lasagna, all the instructions of how to make cannoli, all the instructions of how to make bruschetta. So we can imagine that in memory, an instance of a chef would look something like this. This is a chef, it's just an object. Remember, instances are just objects with a hat color property. And then, as well, a property for every method it has. Make lasagna, make cannoli, make bruschetta. Now, I only have 3 here, but again, a chef probably knows 200 recipes. So imagine having 200 in here. Right? That's a lot to store. Okay? Now, what would this look like if we made a bunch of chefs? Well, here we have chef 1, chef 2, chef 3, chef 4, chef 5, chef 6. They all have their own copy of the make lasagna function. They all have their own copy of make cannoli function. Right? Inside every make lasagna function is the exact same instructions. It's just every chef has to memorize it all over, all new again, right? Again, in this metaphor, every chef has every single 100 list of recipes in their head, right? So I want to first say that even though I've kind of, put down this instantiation pattern, it's completely usable. It's totally fine until you are running large-scale apps where scalability is an issue and you're going to have thousands and thousands of instances. It's fine. It's totally okay to use the functional pattern, right? That being said, out of curiosity, can we think of a way to improve this? Can we think of a way to make the chefs have to memorize less? That'd be cool, right? Well, I want to put forth a proposal. What if, instead of the chefs just memorizing every single recipe cold, what if they all share a cookbook? Right? Then we store the instructions for all the recipes in the cookbook. And this is the idea behind the next instantiation pattern. Functional shared. Now, hopefully you've caught on to the fact that the shared word is included. Shared is included because they all share a central repository, a central book, a central object that has all the functionality on it, and they just know where to find it. Right? So let's imagine that in the chef's brain, in the functional shared pattern, instead of having every single recipe, instead they have a book which they have access to, and in their brain, they have the names of different dishes, and they have memorized the page numbers. So imagine you say, make me lasagna. The chef goes into their head and says, I have memorized that lasagna is associated with the page number 147. Then they can just go straight to the book, open it up, there it is. Now, I want to pause for a second and make sure that we're on the same page of how much better this is, right? I mean, imagine if you had to memorize a single recipe. Like, that's kind of hard. Like, I always use a cookbook. But imagine trying to remember hundreds. Very difficult, right? Takes up a lot of memory. This is a massive improvement. I just want to make sure that you really see how much of a massive improvement this is, right? So how does this look in code? Well, let's go to our last example, which is functional. Just functional, right? Again, what we have here, we create a chef object. At the end, we return it. We set properties directly on chef, and then we set the methods directly on chef, right? So here's my question. Where should these methods go, right? We can't store them on chef anymore because that was the last method. That's where every chef memorizes every recipe. So now where should we store these methods? Well, first we take them out. We don't store them there, like I said. And we create, in the metaphor, a recipe book. We create an empty object. In this case, we're calling it chef recipes. And we store all the methods on that object, right? So I want to make sure this is clear here. We have a chef class which creates instances of chef, and then separately we have an object which stores methods that a chef would use. Right now they're two separate things. They're not yet connected. Which leads you to my next question. How do we actually connect them, right? How do we tell the chef to save a reference to every recipe in his head? It's a great question, and we use something called extend. Now, extend does exactly what we talked about in the chef example. Extend takes two arguments. The first argument here is the object that we want to extend methods to, and the second argument is the object we want to extend methods from. So in this case, we're taking all the methods on chef recipes and putting them onto chef. And once we do this line of code, every instance of chef in their memory has a reference to every method in chef recipes. So when you say make lasagna, they go, oh, I know what that is, and I know exactly where to go to find it. Does that make sense? Oh, there's a car passing. Okay. So let's look at and imagine what an instance of chef looks like in memory, right? What does it look like in code inside a chef's brain, inside a chef object? Well, it looks like this. Again, instances are objects, properties, hat color, and then the make lasagna property, it doesn't store a function. Instead, it stores a reference to the chef recipes object and to the method on that object. Right? Now, in the case of 4 different chefs, instead of every single one creating their own function, they all just reference a shared object that has the functionality there. Right? Chef 1, Chef 2, Chef 3, and Chef 4 are all invoking the same exact function that's in chef recipes because they save a reference to it. They know where to find it. So when you tell them make lasagna, they don't have it in their head, but they know where to find it. Okay? Pretty clever way to do things, right? We've saved a lot of space. We don't have to make it just way more efficient. But again, I want to push us. I want us to keep thinking, how can we be even more efficient? Because right now, if you have 200 recipes, every chef has to memorize the name of 200 recipes and 200 page numbers. So, it's doable, but it's tricky. So I really want us to be ambitious. How can we make this even better? Here's an idea. Here's a proposal. When you want to find a recipe in a recipe book, what do? Do you just start from the top and just flip through until you find it? Do you go page by page? Do you do a logarithmic search where you cut it? No. What do? You look at the table of contents, right? So what if we could just tell the chefs, hey, don't memorize anything. When someone tells you to make a recipe and you don't have it memorized, just look at the table of contents and find the recipe and then make it. And that is the idea behind the next instantiation pattern, prototypical. Instead of memorizing page numbers, the chefs just know to look into the table of contents, right? Don't know it? Check the table of contents. That's all they have memorized. So much easier, right? So let's look at this in code. Here's what we had before. We use extend to make a reference in the chef object to every method in the chef recipes object. Okay? So how do we do this new thing? How do we do this thing where we tell the chef, hey buddy, if you don't know the recipe, just look in the recipe book? How do we create that link? Well, we use something called object.create. Object.create returns a blank object, right? So that's why, notice here, I replaced the blank object here with the invocation of object.create because object.create returns a blank object. And that blank object knows that anytime someone tries to find something on it, anytime someone does a dot access or a bracket access, it knows to first check on itself, see if you know, but if you don't have it, go check in this other object. That's called deferring your object lookups or delegating your object lookups. So in this case, we're creating a chef object, and anytime we do chef dot anything, chef dot make spaghetti, if that method, if that property is not on the chef object, it will go and actually look on this other object, which is the first argument. In this case, chef recipes. Okay? And that's called a prototype chain. That relationship between one object delegating its object lookups, deferring its object lookups, that one object, when it fails, when it can't find something, knowing to look at this other object, that's called a prototype chain. In this case, between chef and chef recipes, there is a prototype chain. So chef will look in chef recipes but cannot find what it needs to in its own object. Okay, let's look at an example. Here we instantiate a new instance of chef. Now, this is what it will look like in the prototypical pattern because we don't actually store anything on it. Right? Before we had extend, which made a reference, but now again, the chef doesn't memorize anything. The chef just knows where to look. Okay? So now we say chef1.make lasagna. If you remember, the chef doesn't have the make lasagna property on it. There's no make lasagna in chef1. So what does it do? Does it throw an error? No. It looks into the chef recipes object for make lasagna. Right? And it finds it, and it runs it. Right? It delegates its failed object lookups to chef recipes. So now the chef doesn't have to know anything because we've told it, listen, buddy, I'll be honest with you. Don't worry about this. If you don't know the recipe, just look in this recipe book. That's it, right? Super, super simple. Now chefs don't have to remember anything. And look, we have 4 chefs, and look how much they have nothing on them. They store almost nothing. And they all know to check the chef recipes object if someone ever asks for something, if someone ever says dot something, if someone ever says square bracket something and they don't have it, check this other object. Okay? Just like our example. Don't know it? Just check the book. Okay? Now, you may remember at the beginning of this lecture, I said there are 4 instantiation patterns. So far I've been through functional, shared, and prototypical. But there's one more. And so far we've been improving the memory every time. It's been getting easier and easier to remember. But how can we improve this? Can we improve this? Can we make this even easier for the chefs to remember? No. Turns out we can't. Which brings me to this important principle. This is what the final instantiation pattern is called. It's called Pseudo-Classical. This brings me to an important principle called Syntactic Sugar. What is Syntactic Sugar? First of all, let's take it one word at a time. Syntactic. Root word, syntax. Syntax, how you write things in code. So the syntax of a for loop is for, open paren, var, single equal sign, I, single equal sign, 0, semicolon, etc., etc., etc. Syntax is what you literally write to make your code run. Okay? Sugar means sweetening things up, taking something bitter and making it a little sweeter. So what would that mean? Put those words together. What could it mean, syntactic sugar? It means making it easier for you to write code. Like, you don't have to write as much code. It's easier. We just do some of the stuff automatically. Okay? So to kind of give you an example of how this would come about, let's imagine you were the creator of JavaScript. So you're this master of like a lower level language like C, and you are very ambitious one weekend and you write all of JavaScript. And you push it out to the multitudes, and hundreds of thousands of people begin using it. And it's wonderful and it's exciting, and a month later you check in, you see what people are doing, and you notice that everyone's doing the same thing. Everyone is doing the prototypical instantiation pattern. Whenever somebody makes classes, they use object.create, and they return the object, and they use a prototype chain, and they're all doing the same thing. And you think to yourself, what could I do as the creator of JavaScript? What could I release in the next version of JavaScript that would make this even easier for the people? Could I sprinkle on a little syntactic sugar such that they wouldn't have to write as much code? And that is the question that inspired the final instantiation pattern. Functionally, memory-wise, it's the same as prototypical, but there's some syntactic sugar on top that just literally makes it easier for you to write. Okay? So, here were the things that we do every time we write prototypical. The creator of JavaScript noticed these recurring themes. People in prototypical always create an object to hold the methods. People always create an instance using object.create with a prototype chain to their object that holds the methods, and they always return the object. So these are the three things that every time are the same. How can we make JavaScript do this automatically? What can we put in the language to make it do it automatically? Well, that's syntactic sugar. That's the exact question that syntactic sugar covers, right? So let's take it one at a time. First of all, everyone always creates an object to store their methods. So what if we say, you know what? I don't want people to have to create an object to store their methods every time. Let's just build in a blank object. Let's just make one automatically. That's what they did. Turns out that creators of JavaScript, on every function object, which is this, they have a property called .prototype. .prototype equals an empty object. And it's specifically made to store the functionality, the methods of a class. So that's the first change. We actually don't have to create that anymore. And instead of storing our methods on chef recipes, we store our methods on chef.prototype, which again is just an empty object that's built in to JavaScript, and it's built in onto the function object. Now, if you get confused here, remember everything in JavaScript is objects, so you can set properties on functions. We're defining a function here called chef, and you could set something called chef.chicken equals a string. Right? So there's a blank object built into chef under the key name prototype. Okay? So that's the first change. Now we get to, and we also have to change this here because chef recipes doesn't exist anymore. So we set the prototype chain from chef to chef.prototype. Okay? Now there's one more chunk of work that we do every time. And it's these two lines of code. every time we create a class in the prototypical style, we do these same things. We create a new object with object.create with a prototype chain to class name .prototype. Okay, and then we return it. So how can we do this automatically, right? How can we do this automatically? Well, turns out that the creators of JavaScript set it up in such a way that we can do these two things automatically, replace 2 lines of code with literally 1 word, right? Sounds pretty magical. What is it? How do we do it? Well, let me move these up. And I'm going to create a new instance of the chef class, just so I can show you an example. So when I create a new instance, we have to have these lines of code so that the function returns what we want. But there's 1 word we can add in that little blue spot that will make us not have to write out those 2 lines of code. What is this one magical word? The word is new. Dun, dun, dun. When we say the keyword new in front of a function invocation, these 2 lines automatically get inserted. When you write the code, you won't write those 2 lines, and you won't see those 2 lines. But when you actually invoke the function with the keyword new, at runtime, the interpreter will sneak in and insert these 2 lines of code, give you the result, and then disappear. Okay? Now, there's 1 change here, which is instead of chef, because instead of the keyword chef, when we use the keyword, instead of the variable name chef, when we use the keyword new, it gets replaced with this. Right? Small change. Just know that every time you use the keyword new, the name of the instance inside the constructor function, the class function, just gets called this. Okay. Now, to make sure you don't get confused, I'm going to change both of these lines to comments, just so you know that you don't actually have to write this code. Right? The keyword new inserts those 2 lines automatically at invocation. Okay. Here's a question, though. On this line, we are referencing chef, but chef doesn't exist anymore. Chef got renamed, remember? What is the name of chef now? It's this, right? So instead of chef.hatColor, we set it to this.hatColor. Okay? If you want to rewatch the video and go back, this is a tricky thing. So if you want to rewatch, pull it back, right? It's kind of tricky, right? Again, we did 2 changes. I'm going to remove the comments just so you don't get confused, because this is what it really looks like. Okay, we did 2 changes. 1, we used to make an object to put the methods on, but now we use the pre-existing function object.prototype. Okay, and the second thing is we removed the line where we create an object and we add a prototype chain to the .prototype object. We deleted that line. We deleted the return line, and instead we just use the keyword new, which automatically does those 2. Okay? So, in conclusion, let's compare the 4 instantiation patterns we've went over. So let's first compare them from a memory perspective. This chef metaphor, right? Functional, every chef memorizes every recipe. Right? So if you have 10 chefs, they all have memorized how to make lasagna. It takes up a lot of memory, but still completely acceptable for probably any app size you're going to build until you start getting to professional, larger scale applications, right? Functional shared, there's a recipe book that chefs reference, and they've memorized the page numbers. So you tell them, make me some cannoli, I know that's on page 30, and they find it in there. Much less memorization than in the functional pattern, right? Finally, prototypical. Prototypical says, listen, I know you're a chef. I don't want you to have to memorize anything. If you don't know how to make what they're asking for, just look in the book. Right? Finally, pseudo-classical, same thing as prototypical. When it comes to the memory metaphors and like what is created and stored in JavaScript, it's exactly the same. The only difference is some syntactic sugar. Okay? Now let's look at the code. In functional, the class creates a copy of every method and stores a reference to every method for every invocation. So on chef 1, a new version of make lasagna is created, and a new version of make cannoli is created. If we were to do chef 2, a new version of make lasagna is created for chef 2, and a new version of make cannoli is created for chef 2. And these are stored, on the actual instance, right? Functional shared, the functions are stored in a different object. And then we use .extend to give the instance access and reference to every method on the methods object. Prototypical, methods are once again stored on an object we create, but instead of using .extend, we use object.create to build a prototype chain between every instance of the class and the one shared repository of methods. Right? So if on any instance of the class we say .make lasagna or .make cannoli or .anything, they will know to just go look in this other object. Okay? So each instance doesn't really store anything in its mind. It just knows where to look. Finally, on Pseudo-Classical, again, same functionality as Prototypical, just less code. We don't write var chef equals object.create. We don't write that at all. We don't even write a return, because that's what the keyword new does, which we use on instantiation. And instead of storing recipes on a shared object we create, we just store them on the pre-existing .prototype object. Okay? All right, hopefully this was helpful in building your understanding of the instantiation patterns and what the difference is and why they exist, right? If you're still having trouble with this, here's what I'd recommend to do. I'd recommend you try and write out or pen and paper out what you understand so far. Try and explain the differences between the 4 patterns, and then go through and watch this video again. But I hope you enjoyed it. If you've got it already, great work, and I'm very grateful to be able to help you with this, and I hope you pass it on. Thanks a lot.